Hello, students. Very good morning, and I hope you all are doing fine. This is Sayyid Usman Ahmed, Assistant Professor, Department of Computer Engineering at Zakir Hussain College of Engineering and Technology in Aligarh Muslim University. And we today are going to study about a very important topic, which is known as operating system. As this subject is the core of one of the core subject of computer science and engineering, we will covering this subject in a length, and we will be discussing the starting with the basics of operating systems, then moving forward with some intermediate topics, and at the end we will also see some of the advanced topics of this course. And this will be a video series that will cover all this in a certain number of lectures. So starting with the first lecture, let us see the table of content. We will study these four topics in this particular video right now. What is the introduction of the operating system, the abstract view of the computer system, the user's view versus the system's view of this operating system, which is abbreviated as OS. And finally, we will be seeing some of the architectures of computer systems as well in this video. Then we will have lecture 2 on the same line, and we will be covering the complete course with a short lecture series. So let's begin with the introduction part of this topic, which is operating system. An operating system is a program that manages the computer hardware. This is the most simple this definition I have found, and it is summarizing the complete concept of OS. So, as per this definition, operating system is generally a certain set of instructions which we call as programs, which is designed, which is written. Why is it written? It is written to manage the computer hardware. Okay, so whatever is the hardware available to you, the computer software which is called in the program or which is known as operating system to you is used to manage that hardware in an efficient way or in a very effective way. This is known as operating system. Operating system act as an intermediary between computer user and its hardware. Now, the second thing come into picture, which says that there is something called user and there is something called hardware, and OS lies in between these two layers. Okay. So you can sketch a rough diagram in your mind that there is a multi-layer structure in which OS occupies the middle layer, and it is doing a job of like transferring designed to be convenient, while others are designed to be efficient. And while at some more are there which are lies in between these two domains, these two range. One is called convenient, one is called efficient. Okay. So we will see what do you mean by convenient and what do you understand by efficient in the later slides. But as of now, we should understand that operating systems are designed as per the need of the user. Okay. There is no specific one operating system. If even if you talk of Windows come with multiple versions. If we talk of Linux come with multiple versions, and each version has its own plus and minuses or pros and cons, and these pros and cons defines the convenience level and the efficiency level of that OS. So, moving ahead, if we take some examples, the first example is of mainframe operating systems, which are mainly designed to optimize the utilization of a hardware. Okay, mainframe systems generally are the systems on which the heavy load system like processing is done. Okay, or we want that mainframe system to run 24/7 and 365 days. We don't want a shutdown, or we don't want system should be hanging or system should be stopped at any point. Okay, if you know that all the financial transactions generally are done on a mainframe systems. all the stock exchange market, all your like business exchange runs on mainframe. So even if you cannot thought of think of stopping that internet like or stock exchange market for even a second, okay, because it will be a huge loss. So these mainframe systems are heavily loaded and they are designed in such a way that they optimize the utilization of that particular hardware on which they are being deployed. The second type of operating systems are designed for personal computers, and they what they are intended to do is they can range from just playing games to making a business applications. Okay, and anything we can think of in between is also a part of this particular set of scope of this OS, which is designed for our personal computers. Okay, they are there to help business applications. They help to help a student to play games and watching movies or writing some text. You can do anything with their personal computer OS, but it has multiple like uh, areas in which it can be deployed. And lastly, we can have an example of devices that we have seen in the recent years, right? That had been in use, which are called handheld devices. These devices need to provide an environment in which a user can easily interface with the computer to execute program. Now the interaction with the computer has increased with the increase in the handheld devices like PDAs or mobile phones or iPads or whatever devices which you can hold in your hand and you can interact very easily with the system. The user interaction with the program has really gone up, and these because of different type of devices that is there in today's market. There is different type of OS coming up, and these OS need to be efficient and need to be convenient. Sometimes at the same time, they have to take care of uh, both the parameters. Now, a computer system can be divided into four basic components. One is the hardware part and one is the user part. Okay, in between you there is a software layer which comprises of two sections. One is the operating system and one is the application programs. So if we can think of this hardware, so uh, we can make a small change here. We can think of this as a single layer. Okay, so you are having three layers. One is hardware, one is user, and your OS and the program lies somewhere in between. Okay, but internally they are four layers also only, and in this the command is given by the user to the application program. If you want to talk to an OS, you cannot talk to the OS directly. You have to talk to the OS through a application program, and then these application programs in turn will give your instructions in a structured way. Whatever way the operating system understands, it will give that command or that request to the OS. The OS will take the resources of the hardware and executes whatever is needed for your request as per your request, and the system will use this hardware and it will fulfill your request. It will send that response back to the application program, and application program sends that back to the user in an appropriate way, whatever is the way the user GUI has been defined. So the GUI respond as per the operating system. So this is how the components of a computer works, and the request flows from a user and to a operating system and back from the operating system to the user. Now, the hardware generally comprises of CPUs, memories, IOs, and some devices, right? We have know it very well. And application programs generally you can think of as a word processing document or spreadsheets or web browsers that are designed for the user. It is designed for the user that can be in that helps you to interact with the OS. Your request is sent to the OS or within the application programs also. You can talk to your application programs also, but you need the help of OS because OS generally is there to manage the hardware as well the user applications. Now, this is a very general abstract view of a computer system in which we can see that OS lies in between the user and the hardware. Okay. So whenever a user one, if it is using a compiler, it's an application program, and it's asked the operating system to compile something, then what happens is the request will flow from the user to the operating system, and it will require some of the hardware resources. The operating system will make use of these resources, and again will do this compilation and send the response back to the user. Likewise, if you are using an assembler or a text editor or a database or any other application, the application program, the structure will be same. The request will flow from the user to the operating system, and the response will go back from the system to the user after utilizing the hardware resource. So, in short, what we can understand is we need to understand what are the application programs, and we need to understand what are the limitations and what are the scope of operating system. Right now, this operating system, because the users are different, user one, two, three, and four, the user will have a different perspective of an operating system. So in the coming slides, we will understand what are the different perspectives of the operating system from the user's view as well as from the system's view. What a user sees, how a user sees an operating system. First question is this: how a user sees this operating system, and whether you have a different perspective of an OS or the perspective remains the same. So let us see the different perspectives of this OS. A user's view of a computer varies according to the interface being used. Okay, the user generally wants a definite set of functionalities. Okay, the specific set of functionalities. So his perspective or his view of a computer system varies as per the interface which he wants to see. Okay. Likewise, a PC user or a personal computer user wants to maximize the work or play, okay, whatever he's doing. So the goal of such OS should be ease of use along with some attention paid to the performance. Okay, when I thought of a PC, when I have seen this PC for first time in my school, so what my work is, what my intention is to do work on this PC with a smooth like feeling. It's smoothly I can work on this particular PC, and the system should not hang. The system should not have a delay in response and request. So this is the performance basic thing which a user requires. So a PC user generally is interested in the ease of use and the performance aspect of that particular OS. Hardly he or she pays any attention towards the third component of the property of an OS, that is called resource utilization. Okay, I am not concerned what resources are being consumed or what resources are being used in the OS. Okay, whether the OS is consuming more resources or it is consuming a less resource. If I get an ease of use and performance like parameters getting right for me, it is right for me. I'm okay with the OS. But the thing is, these are three parameters: ease of use, performance, and resource utilization that should be paid attention. But for a PC user, the third component is very less, less considered for like for like is involved. What I mean say, the third resource, that is called resource utilization, has very less attention is paid to this particular parameter and more to the ease of use and performance parameters. The second type of users perspective is when the user is sitting not on only of a PC, that is an individual user, but now he is sitting on a terminal. Okay. A terminal is a particular type of PC, or you can say a specific type of PC, which is connected to a mainframe or a mini computer or which there are many main terminals to the same mainframe computers. Likewise, there may be many users using similar terminals. You can think of such a scenario when you are sitting in a computer lab, when you are sitting on a like a system, and what you need to access, you need to share some common resources or may exchange information as well. So in this case, you are not the one who is going to, you are not the only one owner of this PC. Now your PC is in a network and you are sharing some common resources and you may exchange some of the information. The OS for such a system then should take care of the resource utilization in addition to ease of use and performance. Now you need we have now we can see that this thing of resource utilization should be again has gone some momentum. It's got some momentum. He has some value. It is some of some like importance. So this resource utilization should take care, and this includes the CPU time, the memory, and I/O usage. Because the more the system, the mainframe is overloaded, right, with the requests, with the processing speed or processing jobs, then it will affect the performance of that particular server. So in this case, all three parameters are very important. The third view of the operating system is from the perspective of a user who is sitting at a workstation, right? Now, this terminal and workstation generally are used in like interchangeably, but this workstation is a little bit different from terminal. What we say is there's still say workstation are connected by networks of other workstations and servers. That means there is a certain set of computers that are connected through a network. Okay, they are on one network. Now, if they want to communicate with another set of networks, they need to go through a particular server. So, in a terminal, all the systems are connected to a same server. Okay, there are no interconnects between them, but in this case there is an interconnect between these systems. You can see this is an interconnect between these systems, and the system will again be connected to another set of workstations, maybe here, right, which will go via this server, right, and all of them can access this particular piece of network, the printer. The printer is common with all the workstations in this particular network. So they here you can see this. These users have a dedicated resource. That means they themselves have some CPU and some like resources available, right? They are using their own resource. With this resource, they are again connected to this networking devices and servers, right? These networking devices and servers. This is common with the particular system. So the OS of such a system is to be designed, which is in which designs to compromise between individual usability, which is called efficient, like ease of use or convenience, and resource utilization, which is like efficiency. So, workstations generally can be seen in IT companies in which certain set of teams sit in one workstations and other set of teams sit with other workstations. They had to utilize their own resource which are available to them, and they have to utilize they share some of the common resources with some of the servers, okay, some of the networking devices also. So in these type of OS which are deployed in this scenario has to compromise between the individual usability and the resource utilization part. They have to take both the things in hand. Now, the fourth type of device that a user generally use is called handheld device, and these devices in recent times had we had seen a lot of exposure of user with these type of devices, and they are mostly standalone mode. They work in a mostly standalone mode. You don't need any other device to work with this particular set of devices. They are running on their own, and but With this, they have some limitations of power, the speed, and interface. They can do some different functions only because they have a limitation of the power that they consume, the speed at which they can run, and the interface that they are designed to work with. The individual usability is the main concern for these OS. As apart from the usability part, the ease of use part, there had to be one more parameter which we haven't seen in the past, which is called the performance per unit of battery life. That means because these are standalone devices, they need to be charged. If I have a mobile phone and it is totally discharged, it is of no use to me, right? Or if you have having a shopping card, you have a credit card or a debit card, and you go to a shopping mall, and the POS device is off, is not charged, so it of no use to you. So the per unit battery life is a very important factor of these devices, and these devices are designed in order to have a larger battery life. Even if you use for 24 hours, the battery should not die soon. So whenever you go and buy a mobile, or you go buy any handheld device, you need to see what is the mAh battery of that particular device. Lastly, the users generally use some of the system which does not have a user interface. Okay, which doesn't have a like user interface like what we have seen in the past. Okay, there are some computers with very little or no user view. For example, embedded computers in the home device and automobiles. So we have seen we lots of embedded devices, embedded software devices around us. If we you can see, we have a television, we have a washing machine, we have smart cars, we have a microwave, we have a like smart fridge, and everything we can see, and we can have a look around in our homes. We can see lots of devices which are having embedded computers in them. Okay. They do not have a very advanced interface, but they may be having a numeric keypads or indicators to show the status of a particular device. So their OS are designed to run without user intervention. Okay, so these device doesn't need user intervention. If you give a command to them, they will be doing that command, and they will be then when these are done, they will just respond with a status symbol indicator, maybe a beep, maybe a sound, maybe a like a light, which can show you that thing is been done. Now you can take that thing off, right? So these are the five type of users view of a system, and because of the difference in the opinions, the difference of views, you need to have a different set of OS. Okay, might be the same OS, but a different customized way of each one should have. Now what how system views this OS is covered in the next slide. From a systems view, an operating system is a resource allocator. First of all, system will see OS as someone who assigns the resources to him, right? This is the resource allocator job. It assigns the resources to all the system. Whatever system needs, it will give you the resource, and it will take the resource from you. So in that manner, you can think of an OS as a manager of resources as well. The operating system generally can give you a resource, and it can preempt also from you, that it will just take away the resources from you as well. If you don't require any resource, they will take the resources from you and give it to the process which is requiring this resource at that moment. Along with the resource allocator and a manager role, operating system can also act as a control program. It will just stop you from going into an erroneous state. Okay, into a state where lots of error can occur. Okay, you can which you can make or use the illegal use of the resources. So it will have a role of a control program as well. So systems view generally is that the operating system is a resource allocator and a manager and a control program. I hope this users views and system views are pretty clear now. So we will moving towards
the architecture part. It's the last part of this presentation. Computer system may be organized into a number of different ways. So we can organize a system because what we want is ideally that the system should be able to uh, find a solution to a user's problem. So what you need to do is you need to somehow arrange your system in such a way that the problem is solved. So there are multiple ways in which you can solve a single problem, and this we call it an architecture. So a computer system generally has three type of architecture. We will discuss some here. There might be more somewhere else. One is called single processor systems. One is called multi-processor systems, and one is a clustered system. So let's start with a single processor system. In a single processor system, there's only one general purpose CPU. Okay. So what we have is we have a single processor system in which we have a one general purpose CPU. Now there are lots of devices and how one CPU can manage all this. So in these days there is something called special purpose processors also. But before that, it is this general purpose CPU is used to execute general purpose instruction set, including instructions from the user processes. Okay, what this general CPU do, it will execute all the instructions that is there from the system as well as from the user end. Now, almost all systems today have special purpose processors in form of device specific processors, such as you can see a disk processor or a keyboard processor or a graphic controllers. Everything is there in one particular set of system. Now, what does these things do is they will be doing their own job. They will not be doing a user process. They will never execute a user process, but they will be doing this limited set of instructions. Like if we take of an example of a keyboard, right? The keyboard come with a processor or the controller. So what you do is you will keep on typing the keys, and the keys are being the strokes are being stored somewhere, buffered somewhere, if the CPU is busy. So whenever a CPU has the slot, it will give that command to the particular keyboard things and will print all the things, right? So your thing is not being stopped, but the delay, the interchange is so fast that you cannot see the buffering. You can understand the buffering part. So this type of things happens because you are having a single processor in your system, and the CPU might be busy with some of the jobs. So your job should not hold. But you should able to keep working with your particular system. So all of these special purpose processors run a limited instruction set and do not use user processors. Sometimes they are managed by OS as well. Now, in contrast to a single processor system, you have multi-processor systems also. They are systems which are having multiple processors. They are known as parallel system or tightly coupled systems. Such systems have more than two processors. These processors are in close communication, sharing the computer bus, sometimes the clock and memory and peripheral devices. Okay, so it's as the name signifies is that these systems have more than one processors working together in a particular system, and they are in communication with each other. Okay, it is not so that one processor is doing something else and other processor is doing something else. They are in communication, and they sometimes they shares the common buses or your clock or memory or even the peripheral devices. What is the main advantage of multiprocessor system? I have noted three. There might be more. The first is increased throughput. Second is economy of scale, and third is the increased reliability. Uh, Increased throughput generally means that you can do now much work with less in less time. Economy of scale means the cost of like a multi-process system is generally less than the equivalent single processors. If you use a single equivalent processors, they will cost you more than having a multi processor system. And finally, the reliability part, which says the multi-processor systems are more reliable, that they reduce failure rate. If a if you fail one processor fails, the system is still in a state of its working state. Now, these multiprocessor systems are of two types. So you can say symmetric and asymmetric, and we will see some of the multiprocessor like dual core or the blade servers in the upcoming slide as well. So, what is a symmetric multiprocessor? First of all, let us understand asymmetric multiprocessors. In asymmetric multiprocessors, each processor is assigned a specific task. If you thought of two processors, so every processor has a specific task. Okay. In this, there is a master-slave type of architecture relationship. One processor is the master, and another processor is the slave. So, master's job is to assign the job to the slave processors. Okay, so and take the response and manage the system. The master processor controls the system. It schedules and allocates works to the slave processors. The other processors either look to the master for instruction or have the predefined task. So if a processor is designed to manage some of the resources, so what it does is it will either look for the instruction from the masters. If it doesn't have an instruction from the master, it will keep doing whatever job has been assigned to that particular processor. Otherwise, the whatever thing has been assigned from the master, it has a priority, and the processor will do that particular job set of tasks. This is called asymmetric multiprocessors. Now, symmetric multiprocessors also have multiple processors because they are family of multiprocessor system, but in this they don't have any master slave relationship. Okay, they don't have a master slave relationship. Each processor performs all tasks within the operating system. Whatever task has been given by the operating system, they all will do um, an equivalent scale. Okay, they don't have a master slave processor because they are considered themselves as peers. Peers are those is the name is a term used when you and another person work in the same organization at the same hierarchy level. Okay, both are peers. Each processor has its set of registers and cache, but all share the same physical memory. As we can see here that there are three processors, 1, 0, 1 and 2, and they are accessing a same central memory, physical memory. They are using the same physical memory, but along with the physical memory, each has its own registers and each has its own cache. Okay, this will speed up the processing uh, part, and as well as they will be having access to the central memory. All three will have central access to the uh, central memory. So this is how symmetric and asymmetric multiprocessors generally differ, and in time of execution and architecture as well. There is something called a dual core design, which is enhancement of symmetric multiprocessor. In symmetric multiprocessor, you are having multiple processors on a multiple chip. Okay. Now in a dual core, you are having two processors on a single chip. You have two processors that is there on a particular one chip. So a recent trend of CPU design is to include multiple computing cores on a single chip. You have multiple cores that are there on a single chip. What is the advantage of this? This on chip communication is better than the between chip communication. You are having multiple chips, so multiple chips communication is less efficient than the on chip communication. Okay, it uses significantly less power than the multiple single chip communications. Okay, you have multiple single chips, they will consume more power than the power that is consumed by a single chip, and you have multiple cores on it. So this is one of the advanced version of the symmetric part of the multiprocessor. Now, with this, we also have something called blade servers. The blade servers are a recent development in which multiple processor boards, like I/O boards, networking boards, are placed in the same chassis. So, as you can see here, there is an example. There is a image taken from Opcore, which shows you a blade server. So, it has multiple like processor boards placed in one chassis, same chassis, right? Each blade processor boots independently and runs in its own operating system. So I can have multiple operating systems for different blades also. Okay, I have this is in Linux and this is in OS like Windows and this is something else I can put. So same some blade servers board with multiprocessors as well. So you can have a single processor server or a multiprocessor server. These servers consist of multiple independent multiprocessor systems. So you as already mentioned the part third that some of them can have multiprocessors, so they can just work independently as well. Now the third type of architecture is called clustered architecture. It looks same as a multiprocessor, but it has some differences. The cluster system is a multiple CPU system, right? Same as multiprocessor, but it looks like it is same as multiprocessor, but it's not same as multiprocessor system. Although the diagram is almost same, but if you can see closely, there's the CPU is called node, and they all access the same memory as well. But along with this, the difference is they are still connected with each other. Okay, it composed of more than two individual systems joined through a via a LAN or a fast interconnect. Okay, why we do this is clustering is done to provide two functionality. One is called high availability service and another is high performance computing. Right, high availability service means the service will continue even if one or more system fails. So excuse me for this extra e. Service will continue even if one or more system fails. So if you think that if your system will fail for CPU 3, the system will be accessible somehow, right? If you think this node goes off. Okay, so what I mean is if this things goes off, this node is not accessible directly, but you can access this via node CPU2. Okay, so the reliability of system is more in this case. And the second part is high performance computing. It says that it's capable of running an application concurrently in all the nodes, so I can run a single piece of application all in all three nodes at same time. Okay, or if I can do that, I can distribute it's say A1, a part of the job into A2, on second job, and I have A3. So I can compute A1 plus A2 plus A3 and put it back to the storage. Okay, I can distribute or I can have parallel communications also. But all these things will enhance my computing power. So let's see what is high availability mode. High availability mode is it comes in two variants. One is called symmetric clustering. One is called asymmetric clustering. Symmetric clustering generally means in one machine is in hot standby mode, right? So if I think of two machines, one is this machine and one is this machine, right? Currently, you say that this is an active machine. It is being connected to a network, a set of network somewhere, right? It is giving the role is to take care of this network. So at this point, this device is active and this device is host standby mode. Okay, host hot standby mode. So this is in inactive mode. As soon if this device goes down somehow, right, your connection with this device will be like set up, right? The host machine does nothing but monitor the active device. This is the device which is constantly monitoring this active node, right? If the server fails, the hot standby mode house become active to a server. So in this case, what happens is you will never lose your connectivity. The client and doesn't feel that the loss of connectivity is there, and it will still access the uh, devices or the functionality or the services. This type of thing generally comes into play where you have a network in place. Like if we think of a a person sitting in organization somewhere here, right? And he wants to access internet via a particular server. This is the internet, right? So if I have a single device and this device goes down, there's no way that person can access the internet. So what we do is we will create another device which is in HA mode, what is a high availability mode. And if this device goes down, the connectivity is still available from the hot standby mode device. The second is symmetric clustering, in which both the devices are running in parallel. They are running simultaneously, right? And they are monitoring each other. So this second asymmetric mode is in this, it requires that more than one app programs is running on the is more than one application is available to run, and secondly is it is more efficient than the hot standby mode, right? Because at this time you are using both the device actively. uh, High performance computing, it's mentioned that it's capable of running an application concurrently on all the nodes. This can be done either by distributed computing or parallel computing. Distribution itself involves a flavor of parallelism. We said that dividing a program into separate set of components that run in parallel on the individual computers in the clusters, which is called as nodes, and the result of from all the nodes are combined into a final solution. So, as I have mentioned in my previous slides somewhere, here, yes, here, that you are having a job called A. So you divided the job A into three components: A1, A2, and A3, right? And then you distribute it on the all three nodes. Now once you get the response, what you can do is you can do A1 plus A2 plus A3, right? Plus A3. So in this way you can combine all three jobs and you can accomplish your task. Now if you cannot do that, then what happens is sometimes it's happened like in the scenario you are sitting at one location and your team is sitting in another location, and further the team is sitting in another location. You are having three different locations. So what generally does it, what we do is we will have a central storage somewhere, right? We have central storage, and this is one location, this is another location, right? So both the location are accessing the same set of storages, right? And then these two teams will be doing the computation parallelly on the same storage. Okay, so it will not be happening that once one team does, it will inform the other team, then it will the other team will take away the work. So it involves parallel clusters over wide area network, because they are not sitting in a same geographical location. When you have a different geographical location, then you need to have you cannot work with a LAN based system. Then you need to have a wide area network. Multiple hosts can access the same data that is there on the shared storage, right? And to manage, because you are having a shared storage here, right, you need to have access control and locking mechanism in place. So if you have already studied in your databases that whenever you are going to access a same piece of code, then in that case what you need is there should be something called locking should be in place. If you want to read the shared content, then the shared lock is imposed. If you want to do a write operation on a particular shared piece of code, then you need to have an exclusive lock, because you don't want multiple people to write on the same piece of the same piece of data. You cannot access, multiple people should not write, it is illegal operation. So this is how you can achieve your high performance computing. Uh, and with this, we come to the end of this lecture one. In the next lecture, we will be studying about the operating system structure, and further we will have many more topics to cover up the complete syllabus that this is related to the operating system. In case anything is not clear or you have any doubts, you have any queries, you can just write to me at this email ID, and I will try to respond as soon as possible. Thank you very much, and have a nice day.